Alright guys, I got a quick video for you on GCF, greatest common factor, and dividing monomials. Okay? So I'm pretty sure GCF is something that you did in middle school, but we'll do a quick recap. So a couple definitions I want to make sure we get down. First, factors. So factors are, if I give you some number, factors are the things that we multiply to get another number. So the factors of 6 are 2 and 3. If I gave you the number 9, right, what are some factors of 9? Well, you could do 1 times 9 or 3 times 3, right? What are the factors of 12? You do 1 times 12, right? 2 times 6 or 3 times 4. These are all my factors of 12. If I ask you to identify a greatest common factor, then I'm saying if I had two numbers, I'm looking for the biggest factor that is shared by both of them. So with 9 and 12, it looks like the biggest factor that they both share would be 3. Right? And we have lots of ways of doing this. One way is to write out all the factors. There's other ways too, but that's something that you should have done before, so I'm not going to get into that too much. If we had 30 and 45, their GCF is 15. It's the biggest number that you can divide both of them by. Something that we're going to think about here is if we have some monomials with variables involved, and we have to find their GCFs. So, 30xy and 45y. Well, they're both divisible by 15, and they both share a y. So their GCF would be 15y. So you're going to do that on your own, practicing finding the GCF between two terms. That's page 3 in your homework. Remember that you got to include the variables. So this is something that we maybe haven't seen so much of, is when I have some monomials, I'm dividing them, and I have variables with exponents involved. So we need to think about what to do here. When we were multiplying variables, we said if I'm multiplying two variables together, I'm going to add the exponents. Well, the opposite of multiplying is dividing. So what do you think you're going to do with the exponents here? Let's take a look at an example. A cubed divided by a. I could write this as a times a times a, all over one single a. So if we're dividing, we'll have an a cancel out from both, and what we're left with is a times a on the top, or just a squared. I could write it as a squared over 1, that's fine, or just a squared. So what did I do? I had a cubed on the bottom, or a cubed on top, a to the 1 on bottom. If we think about it, what we really did is we did a to the 3 minus 1. We took away the 1a that was on the bottom. So when I'm dividing monomials, I'm going to subtract the exponents. Okay, I'm going to subtract the exponents. So kind of rule of thumb here, if I'm dividing two monomials, I'm going to subtract any exponents. Okay, that's one way to do it. So looking at this here, and we'll simplify any coefficients we have too. So looking at the second one, b to the 6th over b cubed. So 6 minus 3. C to the 5th over c squared, 5 minus 2. We could write it out this way, right? 6 minus 3 is 3. 5 minus 2 is also 3. if you're having trouble doing it this way, you could do it the long way, where you take b to the 6th and you expand it as 6b's all multiplied together, 5c's all multiplied together. You can see how this gets pretty tedious though. 3b's on the bottom, 2c's on the bottom. Okay, if we do it this way, we can visualize our cancellation here. So I lose 1, 2, 3b's, and 2c's. I'm left with 3b's, b cubed, and 3c's, c cubed. Or we could just subtract. Okay. For something like this, where I have 24 over 12, simplify that fraction, the way you normally do. So 24 divided by 12 is, what, 2 over 1. Okay? If I'm looking at my x's, I'm going to do this two ways. The first way I'm going to do it is I'm going to subtract the exponents. The second way I'm going to do it, I think you might like a little better. So I'm going to do top minus bottom, 2 minus 5. And that's, let's see, x to the negative 3. Okay. Now we talked about negative exponents. We said that if you have a negative exponent, you want to move whatever has the negative exponent attached to it to the bottom of a fraction. So I would rewrite this as 2 over x cubed. Really, if you have a negative exponent, it means to flip the whatever side it's on. So if this was on the bottom to begin with, it would go up top. Since it was at the top, it goes to the bottom. The other way we could think about this is, I'm going to deal with the 24 over 12. I know that leaves me with a 2 on top. I can just think to myself, what side of this fraction has the bigger exponent? Well, the bigger exponent is on the bottom, right? Because the bigger exponent is on the bottom, that means that that variable, that x, is going to stay on the bottom when I divide. So we're going to lose the x on top. How much bigger is 5 than 2? Well, the difference between 5 and 2 is 3. So I'll be left with an x cubed on top. So that's the way I like to think of it. I'll take 2 away from the 5 here. And you're really doing the same thing, but conceptually it's a little bit easier.